Alright, hi Year 12, this is Mr. Lim here again, and this is a special request for a question from the worksheets, question number 6 and 7 and number 4. I can't remember which one's which, so let's just get started. Okay, so question 6, student would like to create a buffer of hydrofluoric acid and fluoride ions. If he has 200 mils of 1.5 moles per liter hydrofluoric acid, how many grams of solid sodium fluoride should he add to make an equimolar buffer? You should hopefully know the words equimolar. What does that mean? It means it has equal number of moles, which means that we have to work out the number of moles of the hydrofluoric acid first, which will be equal to CV, which will be equal to 1.5 times 0.2, which is like, I don't know, some value. We're going to call it A. Okay, once I have that, I need to recognize that I need, in terms of making a buffer, I need to add the conjugate base of hydrofluoric acid, which happens to be the fluoride ion. But remember, I can't just add fluoride ions by themselves. I have to add them in some sort of salt because the fluoride ions don't exist by themselves. So the most appropriate salt would be sodium fluoride, which is why it's listed there. So I would need the same number of moles of sodium fluoride as the number of moles of HF because I want it to be equimolar, so therefore it's that value A. Since I want that value A of things, and I need to have a mass, so I need to have the mass of sodium fluoride, which would be equal to N times big M. Then it would be A or times whatever the big M of NaF is, which would get me some value, and that would be in grams. Okay, so that is what that one would be. Okay, that's how you would do it. Please remember that you cannot have the F minus ions by themselves. You have to have them in some sort of salt. Okay, in this case it's sodium fluoride, but just remember in your buffers, you have to provide the salt of the of whatever the weak acid or the weak base is. Salt of the conjugate acid or base of the weak acid or base. Okay. Chemist is making a buffer solution to calibrate a pH meter. He creates an ethanoic acid sodium ethanoate buffer solution, but finds the pH is too high, okay, which means it's too basic. Name a chemical that she could add to the buffer solution to adjust the pH, and explain how that chemical will lower the pH of that solution. So it might be useful, again, for that one to have a equation. So ethanoic acid, and then we write out the equilibrium equation, so that we can see what's happening with it. Okay, so that's number 6, that's number 7. Okay, so the pH is too high, which means it's too basic, which means that we want to lower the pH by increasing, we want to increase the H plus ions, or H0 plus ion concentration. That's what we want to do. So how can we do that? We can add an acid. Any acid of any sort. Okay. 2 options would be, the best one would be to add more ethanoic acid, so that it just adds to the buffer creating capacity, or you can just add a small amount of strong acid like HCl or something like that. Okay. Why will it do so? Because adding acid will increase the concentration of H3O plus, because that's what acids have in them, okay? And that will lower the pH. Okay, that's what that one is about. All right, then number 4, a student is confused about why universal indicator is added to the distilled water. The solution was yellow instead of green, okay? So what we need to remember is that the self-ionization of water is endothermic. Okay, so if you memorize that, you'll be able to remember that, okay, if it's endothermic, then I know that what the question is telling me, that when I add the universal indicator in, it is yellow. That's pure water which turns yellow. If it's yellow, then it means it's slightly acidic. Okay, and if it's slightly acidic, it means that the H3O plus concentration is slightly higher than 1 times 10 to the negative 7, which would make it green. Okay, so because it's higher than that value, therefore that's why it's yellow. Okay, so that would then indicate that if it's yellow, then it's slightly more acidic, so that there's the concentration of H3O plus is greater than H3O plus at neutral, so 1 times 10 to the negative 7, which would mean that at some point the forward rate of reaction was favored, or there's a net forward rate of reaction which produced more H3O plus ions, right? And the idea is that that increased concentration of H3O plus ions has increased or decreased the pH. Okay, so how do you favor the forward rate of reaction? Okay, that's the question. How do you increase the forward rate of reaction for an endothermic reaction? What we have to do is we have to increase the temperature. Okay, so we can increase the forward rate of reaction or have it in the net reaction if the self-ionization of energy of water is endothermic, if we increase the temperature. Okay, if we increase the temperature, then we will get this slightly yellow solution. And so therefore, was the temperature above or below 25 degrees Celsius? 25 degrees Celsius is important because it makes that value. So it is above 25 degrees Celsius. Okay, so it must be above 25 degrees Celsius, right? And then explain why the solution was yellow instead of green. That's kind of the idea. Yellow because there's a greater concentration of H3O plus. Why is there a greater H3O plus? Because it must be warmer than 25 degrees, which would favor the forward reaction, which would produce more H3O plus, which would then turn it slightly, not even slightly acidic, but it's just that the concentration of H3O plus must be greater than 1 times 10 to the negative 7. All right, and so that is that. Don't ask any more questions because the test is tomorrow. Go do some work. Adios.